Welcome back to our discussion on exploring spatial data with ArcPy. This particular section is going to focus on exploring data by creating lists of data. So once we're inside of a workspace, once we've checked to see if something is there, how do we create a list of what might be within our workspace and why might that be helpful? So to create lists of data using ArcPy, the most common ArcPy list functions are list feature classes, which will list out all of the feature classes in the workspace you've defined. List workspaces, which will list out all of the workspaces, folders, and geodatabases in the location that you are. List fields, which will list out all of the fields for a particular data set. List datasets, which will go through and list a variety of datasets, not just feature classes, both raster and vector. And then list rasters, which will limit to just the raster datasets within a workspace, be it a folder that has grids or a file geodatabase that has a raster file living inside of there. So why are lists useful, and what are some situations where they would be beneficial in your scripting? Well, if you're in a workspace within a script while you're writing it or running it, sometimes it's good to see what's inside of that workspace or folder. One way to troubleshoot and to go through and do some error handling of your scripts is to make sure that whatever data you are wanting to use in the lines below are within the workspace that you've defined. Creating a list of this data is also then paired with iterating through that list with before you go through with a geoprocessing tool. So let's say that there is something that you want to do to every single data set inside of a workspace. You define your workspace. You create a list of all of those data sets that are in the workspace, and let's pretend that we need to migrate everything from one coordinate system to another. We are in the state of Ohio, and we are using the Ohio State plane that is with units of feet, but we want to move things to the Ohio State plane that has a units of meters to be more in line with our organization. So everything within a specific workspace would need to have the project tool run on it. Well, you could create a for loop that would go through and iterate through each individual data set, but it would have to be within a list, right? So your for loop would operate off of a list that you create, and for every item in that list, it would do whatever you have coded inside the for loop. So in this example, a project features tool. So that's one way that is really helpful with lists, is to create a list of them to see what's there, and then also to use those lists in iteration. So each of these list functions returns a Python list. So you are very familiar by now with Python lists. We've played with them a lot up until now. And each also require that a workspace environment be defined. So in order to know what it's looking at, you have to have the workspace environment defined. So let's look at an example. This is an example where, notice the first thing we've done is import ArcPy, because that's very important. We have to be able to import the module in order for the tools to be available to us. The first thing we're going to do is set up our workspace. ArcPy.env workspace is equal to see my data. And just notice here that I've used the convention of the double backslash, and remember that there are multiple ways to do that in Python. And remember, I just recommend that you choose one and stick with it. You can use the single front slash, or you can also use the string R literal in front of your quotations and keep a single backslash. So we've set up the workspace, and then the next thing I'm going to do is I am going to use list feature classes to create a list of all of the feature classes that might exist in this folder. I don't know if anything does at this moment. Now notice also that I'm putting this inside of a variable. So I'm calling this function list feature classes, and I know it's going to create a list. I know that's what it's going to return. So I'm putting that return value inside of a variable called fclist. So fclist is simply going to be a variable that holds the list that's returned by list feature classes. Then next, this should be very familiar. You just went through playing with this for loop in the review before your exam. We're going to use a for loop to go through iteratively everything in that list. And for now, all we're going to do is print it out so that we can see visually what's inside of this workspace. So I'm going to say for fc, and remember that is just a variable defined on the fly. Using fc is just a common geospatial convention, a professional convention of identifying a single feature class in a single list. So fclist is again another common one, but again you could say for tacos in taco bar, print taco, right? So all of these variables can be whatever you want them to be. We're just introducing you to the most common ones used in the geospatial profession. So for fc and fclist, print the FC. So down below you see the output. So apparently there are 6 feature classes in this particular folder, and they are shapefiles, and I know that because they have a .shp on the end, and I also know that because my workspace was set to be a folder. This is not going to list out any geodatabase information for me because a geodatabase itself is not a feature class. It's a workspace, and I'm not inside of a geodatabase, so it can't get in there and list my feature classes. So if my workspace is a folder, the only feature classes I have access to put into this list are shapefiles. All right, so let's look at list feature classes syntax. Syntax is so incredibly important. As you move through this part of the semester and forward, you are going to always be required to include the syntax of every geoprocessing tool and ArcPy tool you use in your script. You can either put them at the top with your header comments, or you can put the syntax as a comment within your script right before you need to use the tool. But understanding what the syntax is and understanding how to read it is going to become incredibly important. So let's look at list feature classes. When we look at the syntax, and we find this by just going to the ArcPro help online for list feature classes, we see that it has 3 parameters available to us. We also see that these 3 parameters are what we call optional because they have those curly brackets along the outside of them. So the 3 optional parameters that we can include in list feature classes are a wildcard, a feature type, and a feature data set. So we're going to walk through these. So what is a wildcard? Well, a wildcard is going to be a string that limits the name of the data. So it's a wildcard that exists in the name of the data set. So you could do, example, you could list out only data sets starting with B. So your wildcard would be a B, and it actually would also have an asterisk on one side of it. So if the asterisk appears on the right side of the letter, it means that B is going to be in front of whatever else it is and following that string. If the asterisk is in front of the B, it means that everything in the data set name leading up to the last character can be anything, but the last character has to be B. For feature type, this is where you get to limit your list to a specific feature type. For example, if you only want to list out the polygons in your workspace, you could put in the feature type of polygons. Feature data set, now remember the feature data set, that terminology is specific to file geodatabases. So this would be only if you had your workspace set to be a file geodatabase. You could put in a specific name of a feature data set, and it would limit the list of the feature classes to only those features that are within that feature data set. So let's look at some actual examples. So in this example, I'm back to my workspace of being my data. Again, because it's a folder, I know that I have access to shapefiles that might live there. Let's play with the wildcard example. So let's list out all the feature classes that might start with W. So notice how the W is a string, so it's put in quotes. And notice there's that asterisk after the W. That means that anything can come after that W. But I am requiring that the first letter of every data set be a W. So here we have list feature classes that start with W. That's going to populate our list, again called FC list, that variable we defined on the fly. For each feature class in our feature class list, print them out. And notice here how we are limited to only 2 shapefiles now, and notice what they have in common. They both start with a W. And for context and for comparison, I just want to show you what the original lines of code looked like there when we did list feature classes without any of its optional parameters. We just put an open and close parentheses and said, hey, we want everything. And with everything, we got 6 feature classes. And with using our wildcard there, we put in the W and we got just 2. Now we could have also used any other letter. But what I want to point out here though with this particular example is if we had put in a wildcard of an O. Look at this. So Oxford city limits, it starts with a lowercase o, and Oxford Township center lines starts with an uppercase O. Remember strings, these two are different. These are not equivalent. So if we wanted to list out everything that started with an O, we could not just put a lowercase o or an uppercase O because it would only grab one of these. So that's something to keep in mind, that our rules of strings and capitalization still play out in this, right? Capitalization matters. All right, so let's look at the feature type example, looking at that optional parameter. Same things, we've imported ArcPy, same workspace. We're using the same tool, list feature classes, but instead of using that wildcard, we want to limit to a particular feature type, and we've chosen polygon. So this will ensure and limit our list that gets outputted into FC list to be only a list of polygon feature classes. But notice how this is structured. If you remember, feature type was the second optional parameter in our syntax. So when you have those optional parameters, if you want to move through them. So if we had just put polygon in here, it would be trying to use polygon as our wildcard, because the wildcard is what it sees as the first optional parameter. So the most classic way to move through and ignore these optional parameters that you don't want to use, but you want to use something in the syntax listed after it, is to put a double set of quotes. And that just means for the software and for the code, that means skip over this. There's nothing to include here. So there's no wildcard being used. We're using the limiter of the feature type of polygon. And notice here we've listed out, apparently, of those six feature classes, those 6 shape files in our workspace, 3 of them are polygons. You don't know that by the name. There's nothing, the last one I had named it with the lake poly, so that the name is telling you something there, but there's nothing in the name of a data set that's going to really necessarily for certain tell you the feature type. So this is how you would determine that inside of your workspace. And again, just for comparison, looking at all of those that were listed out without any of those optional parameters, those 6 data sets of whatever feature type they are. We weren't sure, but now we've limited it to just the polygons, and these are the 3 data sets that are the polygons. Now remember, we don't have an example here with the feature data set because our workspace for this little example code was a folder and not a file geodatabase. But remember, if we were to use that third parameter, optional parameter, if our workspace was a file geodatabase and we only wanted to gain access to that third parameter, we would put in 2 sets of double quotes with a comma between them in order to gain access to that third parameter. Over here, we would put a double quote here, a comma, and then we would put in the name of the feature data set. And as long as our workspace was set up to be a file geodatabase, that it had that feature data set of that name in it, then the list of feature classes, and they would not have any .shp at the end of it, right? Because they're a file geodatabase feature class that has no extension at the end, that would list out all of the feature classes that existed within that file geodatabase. All right, that is your discussion on lists of data, the tools that create lists of data, and some of the common applications of using lists within ArcPy.